Okay, so we're gonna continue to the next lesson. Right now is chapter 4, lesson 8. Please open your book, page 169. So we're not gonna discuss lesson 7, we are skipping it. So we're gonna go to lesson 8 directly. Okay, open your book, page 169. So the title of this lesson is Graphs and Derivatives of Implicit Relation. Yeah. So before we get into the main topic, I want to review about relation first. So there is a function and there is a relation. And actually this is from, actually you have learned this in 10th grade when you are learning the graph of circle, ellipse, hyperbola, and parabola. Yeah. So a function, for a function, there is a condition that needs to be fulfilled, that there, for one value of x, there must be only one value of y. It's a function. But for relation, it doesn't have this boundary. It's not necessarily needed for relation. Yeah. So if we draw the Venn diagram, sample space Venn diagram, then actually all functions will be a relation, but not all relation will be a function. Okay. Now, if you open your book, I'm gonna read it from your book, page 169. If y equals some function of x, such as y equals x squared plus sine x, then there is said to be an explicit relation between x and y. The word explicit comes from the same root as the word explain. So for example, given y equals x squared plus sine x is called explicit relation. So for this chapter, instead of function, we are talking about the general idea of a relation. Yeah, so that's why even though it's a function, I know that y equals x squared plus sine x is a function, but we will call it relation in this lesson. Explicit relation. Why is it explicit relation? Because the dependent variable, the y, is explicitly, is clearly, is described, uh, explicitly explained by the value of x. It means if you substitute the x here, if you substitute the x here, then you will get the value of y directly, right? That's why we call that the y is explicitly explained in this relation. And this kind of relation is called explicit relation. Now, another example, if x and y appear in the equation such as x squared plus y squared equals 25, then there is an implicit relation between x and y because it is only implied that y is a function of x. Okay, so for example, x squared plus y squared equals 25 equal to 25, then this is called an implicit relation. Okay, why? Because the one variable is not expressed directly by another variable. Yeah, it means that if I substitute the value of x, then I still need to change something so that I get the value of y, right? For example, if the x is 3, then I have to 9 plus y squared equals 25. Then I don't get the value of y directly. I have to minus 9 both sides, and I have to square root both sides, so I get plus minus 4. While in explicit relation, if I substitute the x is 90 degrees or pi over 2, then actually I can just get directly the value of y, which is pi squared over 4 plus 1. So that's the difference between explicit relation and implicit relation. Okay. Now, so today we're gonna learn how to derive, how to find dy dx, how to find the derivative of one variable with respect to another variable in implicit relation. which actually have been covered. I have used this technique before when I tried to find the derivative of exponential function. So yeah, let's see example 2 first. Let's see example 2. Page 170. Find dy dx for the implicit relation y power of 4 plus x cubed y power of 5 minus 2x power of 7 equals 13. Okay, so basically you need to find out the dy dx. It means you want to find the derivation of y with respect to x. So the technique is to derive both sides with respect to x. Remember this step? I used this step when I tried to find the formula for the derivative of exponential function. Derive both sides with respect to x, right? Okay. So the first term is y power 4. So this is a composite function. So remember, y is still somehow related to the value of x, right? Because it's relation, so x is related to y and y is related to x. Therefore, actually, y is a composite function of x. So we need to use chain rule. So basically, it's 4y cubed. Now, because y is a function of x, so we need to add the multiplication of the derivative of inside function. Multiply the derivative of inside function, yeah, dy dx. Plus x cubed y power of 5. So this is a product of two functions. So it's u prime phi plus u phi prime y power 5. So y 5y power 4 times dy dx. Yeah, so this is the derivative of x cubed y power 5 with respect to x. Minus 2x power 7 with respect to x, so it's just basically 14x power 6 equals 13, 0. The derivative of 13 is 0. Okay, so if I open the parentheses, then I will have 4y cubed times dy dx plus 3x squared y power 5 plus 5x cubed y power 4 dy dx minus 14x power 6 equals 0. Okay. Now we want to find dy dx, right? We want to find dy dx, so we gather the one that has a dy dx and we eliminate the terms that doesn't have dy dx. Okay. So 4y cubed plus 5x squared y power 4 x cubed, I mean. And then I factor out the dy dx. Okay, is equal to, so plus 14x power 6 both side minus 3x squared y power 5 both side. Yeah. So now we can just find the dy dx by dividing the coefficient. So 14x power 6 minus 3x squared y power 5 over 4y cubed plus 5x cubed y power 4. So this is the value of the dy dx. Now usually I told you that you need to change the y into x if it is a function, right? But when we are talking about this lesson, in particular deriving a relation, you don't need to do that. So it's okay to have this as your final answer. Yeah. So next I'm gonna read to you the technique, page 171. Technique implicit differentiation. To find dy dx for a relation whose equation is written implicitly, first differentiate both sides of the equation with respect to x. Okay, this is what I did. Differentiate both sides with respect to x. Okay, obey the chain rule by multiplying by dy dx. Obey the chain rule by multiplying the dy dx. Each time you differentiate an expression containing y, and then isolate dy dx. This is what I did to isolate it by getting all the dy dx terms onto one side the equation and all other terms into the other side. then factor it if necessary, divide both sides with the coefficient of dy dx. So that's basically how you do the derivative of implicit relation. Okay, so before I end this lesson, I want to give you another example, which is example 1. Consider the implicit relation x squared plus y squared equals 25. Plot in figure 4.98a. Yeah, you can see the figure. It's a circle. Explain why the graph is a circle. Well, basically, if you still remember your algebra class about circle, basically the general equation of a circle is x minus a squared plus y minus b squared equals to radius squared, right? So basically, of course, x squared plus y squared equals 25 is a circle with a center of 0, 0 and the radius of 5. Yeah. Now differentiate implicitly to find dy dx. So we have x squared plus y squared equals 25, and then we want to find dy dx. So we need to derive with both sides with respect to x. Okay. So we have 2x plus 2y times dy dx equals 0. Okay, and then I minus subtract with 2x both sides, and then I divide both sides with 2y, so I will have negative x over y. So this is the formula for the dy dx. Okay, and then calculate the two values when when x equals 3. So when x equals 3, it means that 9 plus y squared equals to 25, y squared equals to 16, and y equals to positive or negative 4. Okay. Draw a line with slope dy dx to the point found in part C with the lower value of y. How is this line related to the graph? Okay, I'll try to draw it. Let's say that this is a okay, and let's say I know it's not gonna be good because I'm not using. Okay, let's just try. Okay, and let's say that this is x squared plus y squared equals 25. It means that the radius is 5, so this is 5, and this is 5, negative 5, negative 5. Okay, now let's find dy dx when x equals 3 and y equals a lower value of y, so negative 4. Then actually the dy dx is actually equal to negative 3 over negative 4, which is 3 over 4, yeah? 3 over 4. Okay. So when it's 3 comma negative 4, let's say that this is the point, this is 3 and negative 4. The slope is 3 over 4. And then draw the slope of 3 over 4. Supposedly, if you do it correctly, then this line will be the slope, the tangent line. Yeah, it's supposed to be a tangent line. Why? Because the definition of dy dx is graphically is a slope of the tangent line, right? So if you have a point and you draw a slope of dy dx, then you must get the tangent line. So if you see the graph, it's clearly on figure 4.8b. It's definitely the slope of the tangent line, and to show it, it's supposed to be it's 3 and 4. The rise is 3 and the run is 4. I know it's not accurate because I'm using a sketch, but if you do it correctly, you must get the right answer. Okay, so that's all for today. I hope from this lesson you're able to derive to find the dy dx of implicit relation. Thank you.